Public IP addresses are vital in Azure for enabling resources within virtual networks to communicate with external services. In previous segments, we examined the creation of virtual networks, subnets, and peering mechanisms, establishing a foundational structure for Azure connectivity. Public IPs extend these capabilities by offering globally unique addresses for services requiring internet-facing communication. They facilitate inbound requests, remote administration, and the exposure of selected applications or endpoints. By assigning a public IP to a resource, administrators can manage traffic flows effectively and apply security and routing rules. This approach is especially relevant for virtual machines, load balancers, and application gateways. When configuring public IP addresses, Azure allows two main allocation methods: dynamic and static. Dynamic addresses are assigned at resource creation or startup, meaning the associated IP can change if the resource is deallocated or stopped. This approach is useful for short-lived workloads or applications that do not require a consistent public endpoint. Conversely, static IP addresses remain fixed and never change, providing reliable connections for services that need stable A-record mappings or SSL certificates. Choosing between dynamic and static allocation often depends on the importance of maintaining a persistent public hostname and the cost efficiency of IP address usage. Azure supports both IPv4 and IPv6 public addresses to accommodate diverse networking needs. IPv4 remains prevalent for most deployments, ensuring compatibility with existing systems. However, as the global IPv4 pool diminishes, many organizations include IPv6 addresses for enhanced scalability. Implementing dual-stack approaches allows workloads to handle requests over both protocols. Azure provides separate public IP resource options for IPv4 only, IPv6 only, or dual-stack configurations. Administrators can direct traffic over IPv6 for modern clients while retaining IPv4 endpoints for backward compatibility. This flexibility is increasingly relevant for regions where IPv6 adoption is growing, reducing reliance on scarce IPv4 allocations. Azure offers basic and standard SKUs for public IP addresses, each intended for different scenarios. Basic SKU public IPs provide a simple, cost-effective option for non-critical workloads. They lack advanced features, such as zone redundancy or configurable outbound settings. Standard SKU public IPs offer higher performance, availability, and security enhancements, including support for availability zones and customizable idle timeouts. Standard SKUs are recommended for production workloads to ensure robust end-to-end connectivity. While basic SKUs may suffice for proof-of-concept environments or low-traffic applications, organizations typically prefer the standard SKU in enterprise deployments due to its enhanced reliability and scalability. Public IP addresses can be associated with several resource types. Virtual machines often require public IP addresses to allow inbound traffic, particularly for remote administration via RDP or SSH. Additionally, Azure load balancers and application gateways rely on public IPs to route traffic from external clients to internal endpoints. VPN gateways leverage these addresses for secure external connections and site-to-site tunnels. In each scenario, care must be taken to assign the correct version, IPv4 or IPv6. Choose an appropriate SKU and ensure the IP is allocated in the correct region and resource group to align with the organization's networking design. Using the Azure portal streamlines public IP address creation. Administrators navigate to create a resource and select public IP address. They choose whether to allocate IPv4 or IPv6, designate dynamic or static assignment, and pick the SKU tier. A name, region, and subscription are specified, followed by resource group selection for logical organization. Advanced settings, such as DNS label configuration, can be added if a custom domain name is desired. Once deployed, the new public IP resource appears in the Azure Portal's resource list, allowing further association with virtual machines, load balancers, or other compatible Azure services as needed. Azure CLI offers command line efficiency for public IP configuration. Users first confirm their subscription context, then run a command such as bash AZ network public IP create backslash resource group my resource group backslash name my public IP backslash SKU standard backslash allocation method static backslash DNS name unique host. This example specifies a standard SKU static allocation and a custom DNS label. The created public IP resource becomes available for association with a network interface, load balancer, or other service. Such commands can be integrated into automation scripts or deployment pipelines for consistent, repeatable network configurations. Azure Resource Manager, ARM, templates provide the infrastructure as code approach for consistently deploying public IP addresses. An ARM template can define parameters for IP type, SKU, and allocation methods. These templates are version-controlled and can be repeatedly applied across environments to standardize network designs. By declaring resources in JSON format, teams can ensure the same configuration is used in development, staging, and production. ARM templates also enable incremental updates to public IP addresses, making them suitable for large-scale or enterprise deployments. This approach helps implement governance, enforces naming conventions, and reduces human error by adhering to well-defined patterns. Attaching a public IP address to an Azure resource introduces potential security issues. Network security groups, NSGs, and application security groups help protect inbound and outbound flows by filtering traffic based on protocol, source, and destination. Additionally, Azure Firewall or third-party virtual appliances can inspect and control traffic to or from public resources. Administrators often employ just-in-time access for virtual machines, ensuring RDP or SSH ports are temporary and strictly monitored. Rate limiting or traffic analytics can further help manage threats. By combining these technical measures with robust governance, organizations deploy public IP addresses securely while enabling necessary external connectivity. Azure's public IP architecture supports advanced high-availability scenarios. By placing resources behind Azure Load Balancer or Application Gateway with a standard SKU public IP, workload can withstand multi-zone or zone-redundant failures, depending on the selected region. This design distributes traffic across healthy endpoints and automatically reroutes connections if a problem arises. For stateful services, pairing public IP resources with managed disks and availability sets or zones can reduce downtime. Organizations can also integrate public IP addresses with Azure DNS for traffic routing to alternate regions during large-scale outages. These measures enhance resilience for critical services with strict uptime requirements.